take my time and followed up by David, Gyulnazaryn, and then we asked the other panelists to come on stage. So, all yours.
Thank you for the introduction. And as Stefan mentioned, I'm from Huawei. I think all of you know the company or know to it, but I can tell you a few people can pronounce it correctly, me inclusive. So I try to do it the best way I can. So I jump directly into it because when we talk about decarbonization and also for the compute heat part of it, we look into the concept we have, and that is, for instance, how is the grid supplied? And the grid into the data centers also have to be looked into why we were doing it. For instance, in the Nordics, we have what we call the Nordic Initiative Challenge. And that is because we have a lot of renewable energy in the grid. And when you have a lot of renewable energy in the grid, it's very hard to control the consumption for it, because the consumption and production needs to be aligned. This is why we look into different kinds of solutions, where data centers actually can help make this stabilizations of the grid. So we look into two kinds of different ways of going into the data centers. One is directly connected renewable energies, and the other one is to have the grid supplied for the data centers. And connected to that, we can have all kinds of different energy storage systems. What we show here is actually the energy storage systems based on batteries. It could also be power to the X or something else. So before we start, and this also means when you make the energy for a data center, we look into the heat from the data center and how the heat is generated, and we can reuse it again. So why I'm doing this together with OCP is actually because there's a lot of good cooling solutions that actually make a very good heat outcome from the data centers that is very usable for the heat recovery. So I will tell you a little story, so don't get lost in it, and hopefully afterwards you can see there was some sense in it. First, you of course need, when you have a data center, you need to adjust it. You need to optimize it as much as possible. That could be, for instance, be with fluid dynamics or something else in that direction. But when you have optimized it, because all the optimization you use is actually also energy you save. Another part is, the next step is to implement AI in the control and monitoring part of the data center. By including AI there, you have an agile and dynamic way of controlling your data center. It's not only program maintenance anymore, it's actually an AI acting on what's happening. Very skilled technicians. What do you think is the first they look for when they come into a data center? It's not the power efficiency of the UPSs. They use two senses. They listen and they smell. Because they can, by listening, they can see is something wrong, is something running out of the scope, and they smell to see if there's some degassing or something that is in high temperature there. This is where AI also can help go into using all these senses, but also the data we have in there. So now the story starts. Another part for AI is, for instance, how are we controlling the data in the data center? At Huawei, we have what we call Tech for All. This is our sustainable goals, and we have some projects we are running globally. Now we're in Ireland. We actually have a project here in the west coast of Ireland where we use AI solutions to monitor different kinds of whale species because they are disappearing from the coast of Ireland because of pollution. And this pollution is actually noise. So this AI is looking into what kind of noise can be acceptable and what kind of noise cannot be acceptable to make the ferry routes and transportation to avoid to interact with the whales there. And another part is a lake in Austria where there was migratory birds. They normally come there when they come from the Nordics and go to the south, but there's no insects there anymore. So we are trying to monitor why we don't have these insects there. But now the most important part, and this is of course in the Nordics, we have a salmon project. This salmon project is because we have some invasive species coming from the farmed salmon that have escaped into the fjords and rivers in Norway, and actually outcompeting the North Atlantic salmon. For 2 years, we have monitored these salmons, and now we are actually making a new concept to catch it have 2 names. It's the pink salmon or the humpback salmon that is there. So what we have now is we have made a trap for it. So now we know with absolutely the most high that it's the right salmon we have there. We can get them into a trap and we can get them out of the rivers and the fjords. So this is one part. But what does that have to do with data centers and AI? This is actually because when we are working with AI, we can adjust the workloads according to the consumption for data centers. So for instance, the AI projects have different kind of workloads. We have a very fast AI working with the cameras out there in the rivers and the fjords and make the separation. This is not IT anymore, that is OT, operational technologies. But the AI working in the data center, that is the big data AI, where we actually compare all the movies coming in there, and we look into also the fingerprint of the salmon, because today, one salmon, the patterns on the salmon is actually like a fingerprint. That means that we can use these workloads to go into the data centers and see when do we make the workloads and when do we need, for instance, to use the heat recovery, or when do we have a renewable energy available for it. So this is just to show we can adjust the consumption of a data centers with the IT load we have there. This means when we look into the heat recovery part of it, this is a project we are starting in Denmark together with a district heating company. And this is to see, we have with the OCP cooling solutions, we can run in very high temperatures. We can actually run in 40 and 70 degrees on the water set, which means we cannot, and we are not using heat pump for 90% of the energy consumption in the data centers. That is a good demand, and that's also for the energy consumption very good. So when we look into the consumption of the energy in the data center, that is or also for the district heating system, if we can adjust the consumption together with the demand for the data center, then we actually can fulfill the requirement. We produce data when we actually need the district heating. And this is the symbiosis. I really want to promote how can we get the IT load to adjust into the data center to, first of all, use energy when it's green, but also to use the energy when we actually can use it for heat recovery. And this overall concept, we actually had at this very exciting workshop and use case at a PhD school at the IT University this summer, where we are promoting. We had a very, very bright study group working with this, because it's not for the AI. We have the AI. We also have the energy storage system. But this is because we want to lift this system into a blockchain solution. So we have proof of data, proof of work when we use the data there. And then I can tell you, now we look into the cooling solutions and the OCP work in general. Thank you for my part.
Thank you, Henrik. Thank you, Henrik. So, this probably slide is familiar to you guys. You can see there are 2 processes you can see on the slide. At the upper process is a normal data center process. Yeah, energy coming in, ideally renewable energy. It's used on the data center side, and the heat rejection. Yeah, the excess heat from the server is normally blown into the environment, right? And then the other process you can see underneath is the heating or the heat process. Yeah. Again, here you can see here, fossil fuel, gas is used in a boiler house, heating up water, and this water is used then in the end of the day. For example, as you can see here on the slide, it's used for a public swimming pool. And these processes are not interacting with each other. All right, and as we all know, as you see from the graph, fossil fuel, the pricing is high. There are various reasons. There's a war in the Ukraine. There's also, let's say, taxes and so on gas or fossil fuel or oil. And the prices, as you can see from this graph, are high. and fluctuating also big time. Yeah. So this has also an impact, a social impact also there, because of the prices are so high, the wages and also the income can in some cases not really live up to the high prices. So this is a big issue, and that's why we would like to elaborate here in our session about combined heat compute. This is a buzzword used many times. John Summers, my friend John Summers, my other friend, our common friend John LeBan, use it all the time. What is a combined heat compute all about? In the end of the day, what I tried to explain at the beginning is really making use of the heat rejection from the servers, not to blow it into the environment, really have a purpose for this, because in the end of the day, it's like using the energy which is transferred into heat and then make a really useful usage, as you can see here on the slide, for housing, for the heating, and also for the warm tap water. Yeah. Coming back to the data center side, yeah, as you can see here, when it's a heat transfer, you have three possibilities. Yeah, I think John also elaborated on this. In the end of the day, it's the beginning. You can really have an air-cooled server or an air-cooled rack, and then of course at a certain application running there, at a certain density, there are different thresholds. You need to switch to another cooling method, which is liquid cooling. And you can see here, it's the direct chip cooling, yeah, the cold plate cooling, or also another possibility which is coming in now, also to the applications when it comes to high performance or AI, increasing the density in a rack. Emergent cooling is also an appropriate mean you need to really apply. And then also with the emergent cooling tank, where you really dive the servers into a liquid, also the heat use functionality is also easy. Yeah, you just need to really connect the heat exchanger to the emergent cooling tank. So these are the possibilities: air, on chip, and liquid, or emergent. Sorry, close to keep it. And on these, I would like to ask David Gyulnazaryn, known as David G in the industry. I would like David to elaborate on this.
Thank you, Stefan. So the idea is that we can make heat reuse from all solutions. And in case of conventional air-cooled servers, we take out the air, which is low temperature, let's say 35, 40 degrees, and extract the heat to the liquid, to the water. That water is not warm enough to reuse that. It is lower than the air, so temperatures can be 20, 27 degrees. And with heat pump, we elevate the temperature till 70 degrees, 65 degrees, which is requested by the heat user. And next option is on-chip cooling. So in well-performed servers, we can achieve 80% heat rejection through the CPU and GPU. In this case, the temperature from on-chip can be much higher. We can achieve even 65, 70 degrees in some cases. But the rest still air-cooled, and we use the same approach as in previous slide. And the third one is when we use immersion cooling, there is 100% heat rejection converted to the liquid form. Temperatures can be lower, but overall efficiency is higher. And when we look for that center, it's one approach. We look for the efficiency, we look for the money. But when we look from the point of view of heat user, which can host the IT equipment and the racks, they have another benchmark. They want to provide less energy input, less space for the racks, want to have higher density and higher temperature. So this is another story, but it has to be taken into account. So when we shift to the heat reuse, combined with compute, we reduce the natural gas consumption, we use less boiler houses, and we don't release the heat rejection to the environment. We dedicate that heat to in the place where it's needed. And in this case, we have real circular decarbonized economy. So a few words about artificial intelligence at OCP, at Open Compute Project. What is changing now? Right now, there is already in pipeline big projects for megawatts of installed power. And these large deployments require standardized solutions. And holistic design of the data center is changing. So this era of liquid cooling coming with these new AI requirements. And you can see the work which already done in Open Compute Project. So here is 8 GPU server, each GPU 1 kilowatt, so 8 kilowatt in each server, and there is 6 of them. But overall capacity of the rack 68 kilowatt, and 48 kilowatt of them is liquid form, and 14 is air cooled. But we go further, it's not only about the rack, it's also about the whole modular data center. And you can see that there is 16 racks, each one 62 kilowatt, it gives you 994 kilowatt IT load in one modular data center. And if we look for the temperatures, specifics for the Ireland, we can work with dry cooler, which provides 33 degrees inlet temperature. And that temperatures which we see on the side of the internal side, 56 degrees, can be reused for the heating. But at the same time, we have overall PV 1.01 in accordance with OCP design, OCP rack design, where it's not centralized UPS. So this is what is open source. You can use that, anyone can use that, and make that transition from air cooling to liquid cooling, and at the same time make heat reuse. Now we are ready for questions.
Right. Thank you, David. Questions from the audience? It's only the first part. I can see a question there. Yeah, please. Oh, John. Who are we first? Yes, sir. Please go ahead.
So is the temperature of, we had this discussion this morning about the temperature of processing, future temperature. At OCP, they were talking about temperatures dropping. So what are the ramifications of that on the PUE and also the possibility of heat reuse? Obviously, we still need a heat pump. I would prefer, look at the data, for example, Lumi is liquid cooled solution. They are using AMD processors and GPUs, CPUs and GPUs. They can't supply cooling temperature any higher than 32 degrees. They are rejecting it to the district heating system. They have 3 recent heat pumps. Promote the heat to 85 degrees for the district heating network. But their PUE, when they're using the heat pumps, is 1.28. When they use the dry coolers, it's 1.06. So the PUE is also a bad method for this as well. So those are a couple of questions I thought
Thank you, John. Always sophisticated as always. So, would you like to provide a feedback on that?
Yes, so actually you are right that when this heat generated by data center, heat pump is on data center side, it's make effect on their PV. But from point of view of legislation, or you can put that heat pump on the facility company, which can take that on their shoulder, and in that case will be even better than with dry cooler, because there will be no dry cooler. So everything is connected with this dividing. Where is the border? Who is own what?
So does that answer your question?
Yes or no? No, I was going to say, as a provocative question, Henrik, you have that slide, the Facebook slide, which is the nice of all. But when you've got the heat pump and the imaging products, if you look at the ISO PUE or the EF600, you're supplying cooling to the data center.
Yes.
Okay, their argument is I'm giving you heat, so I should claim an ERF. But they're actually getting cooling from the heat pump. So that should be factored into the PUE calculation. It's not. So this is not fair. This is not a level playing field. So that's something that we need to consider in this equation.
Yes.
Also, I think you are bringing a really good thing up here, because one of the things that we need to agree upon is that PUE is PUE. And this is with all the flaws within PUE, that is. But then we have the ISO 30134, and that is sustainable matrix for data centers. There we have 8 metrics, which include PUE, but it also includes energy reuse factor. It also includes carbon usage effectiveness, also how you use the renewable energy. So in my point of view, you cannot use PUE single-handed. You need to compare it with the other metrics. Then you have a picture. And this is because PUE is what it is. You know, if you make a data center and it's running very, very good at the maximum power, you make the testing. But when you operate your servers, you get very energy efficient servers. What about your infrastructure? It's still the same. And that ruins your PUE. So PUE is not prepared to stand alone, in my opinion. Look at the 7 other metrics. Then you have the really combined picture for how the energy and also the sustainability is for data center.
Okay. Okay. John, I think we need to go on, otherwise we're eating up time for the panel. There was one more question, please.
Yes,
go ahead.
I was John in terms of temperatures. It's only when you're getting water into servers at 30 degrees C. We've not seen anything much like that at the moment. Are we going to drive those temperatures up? Because my understanding is, as you drive the temperatures up, the performance of the service goes down, and for the IT guys, nothing like that.
Anyone answer this?
I didn't catch questions. Can you repeat question?
Basically, it's about the operating temperature of the servers. If it's even increasing above 35 degrees, this is my understanding. Would it be possible in the future? This is my understanding, right? Please.
Yeah, the question is really, can you envision that those temperatures are going to be increased above 35 degrees C on the server? Because the manufacturers at the moment we're speaking to are saying, no, that's the optimum temperature for the servers.
Yes. So I can answer on that question. So when we decide the temperature, what temperature should be in cold dial on inlet into the server, we should look on the manual of the server. And if you look for the example for Dell servers, they have different models, and it depends from the TDP of the CPU. So in some cases, you can have 30 degrees. In some cases, when you have higher TDP, but the same heatsink, you should decrease the temperature till 20 degrees. But when you shift to liquid cooling, you can have 35 degrees inlet air, no matter what TDP of CPU, no matter what is the how many NVMe you have in the front, which create resistance on airflow. So the point that if we take OCP servers, they are dedicated to work with 40 degrees inlet air. So actually, OCP-based data centers don't need cooling equipment like air conditioning, etc. But however, the point is that now more and more we see that the server producers try to increase range of inlet air temperature and to allow to work up to 35 degrees in the air. It's written continuously in their manuals. This is what we can take.
All right, this is answer the question. Thank you very much. We are still around. We're also here tomorrow. So again, this is only was only the first part. I would like to go now to the second part, the panel discussion. So I would like to ask the panelists, Luke, Stefan, and Brian, please come on stage for the second part. Please stay with us. Do not leave. Now it's getting to the interesting part. Please, there are microphones on the seats. Please grab a microphone. Everyone gets a microphone, also you. And I grab the other one here.
Stefan,
Yes, sir.
you can use mine.
Thank you, sir. All right, I'm back on stage, so let's go for the panel discussion. Let's have a quick introductory round. So, I'm only the facilitator, so I'm not important. The important guys are here. These are the data center experts. And again, we are sticking to the topic, combined heat compute, making use of the excess heat from the servers. So, some people probably know me, and also you're realizing I'm not a native speaker. You know, I'm coming from the lovely Bavaria, from Munich. You know, we have this small beer festival called the Oktoberfest. So probably you guys have been there. That's where I'm from. And I'm in independent consulting. I do independent consultancies. I have my own company, but I'm also representing OCP. I'm running the European OCP workstream course on a regular basis, together with my colleague and friend, David. Yeah, please, Henrik, you're the next one.
Yes.
Please.
Hello, can you hear me?
Just wait.
Hello, hello, hello. Hello.
Yes.
Is it working now?
It's working.
It's working. Can you hear me? Oh. Hello. Now?
Yes. Yeah, perfect.
My name is Henrik Børling. I'm the Business Development Director from Huawei, and my responsibility is Denmark, Iceland for commercial parts, and the Nordics for technical parts.
Thank you, Henrik. Next one, David.
My name is David Gyulnazaryn. I'm from France, from Nice, and I'm focusing on data center decarbonization and heat reuse. And at the same time, I'm leading the OCP workstream in Europe and immersion cooling challenges.
Thank you. Next one, Brian.
Good afternoon, everyone. I'm Brian Clayton. I'm involved with battery energy storage and renewables for big users of electricity, whether it's data centers, industrial processes, hospitals, etc. Just forgive me, I'm still sounding young, but I've lived in England for more than 30 years. Anyway, I work both in the UK and here in Ireland to deliver fully funded battery energy storage systems at no cost to the host. And we do a revenue share with the host and provide them with 100% of the carbon benefits that we deliver to them.
Right, thank you. Stefan, please go ahead.
My name is Stefan. I'm from Germany. It's 50 years in London. I'm from Australia. It's a sustainable and important place in London. On the other hand, I also organize conferences for data centers in Vietnam and also data center in the data center.
Thank you. Last but not least, Luke.
Thank you. My name is Luke, from Bossaert, Belgium. I'm CEO of DataCentres, and we look at electricity consumption and data centers. Basically, through data analytics, we reduce the electricity consumption at data centers.
Thank you, Luke. As you can see, a really international group. I think people from 5 different nations. So I just picking now this handsome guy in the middle, Brian. The first question to you, as an expert when it comes to, let's say, battery storage, can you possibly share with the audience the main advantages of you just mentioned your BESS system, the battery storage system, together with the solar panel solution. What are the main advantages you're offering there?
Certainly. The main 2 advantages are cost savings and carbon savings, all achieved at no cost to the host. So anybody here who either runs a data center or is involved in a data center, we can provide a fully funded delivery of battery energy storage systems, on-site, near-site solar, and in fact we can actually build microgrids on behalf of big users of electricity in the UK and here in Ireland. The technologies and physics work around the world, but the regulatory environments are different. So we've focused here in Ireland and in the UK.
Thank you, Brian. Next one, David. Please, again, as you are the most sophisticated engineer I'm aware of in the industry, please, in your words, not in my simple words, please explain to the audience again, combined heat compute, what is it all about?
Combined heat compute is about circularity, about reuse, about environmental impact. So when we have comprehensive approach to human activity, and when we combine and IT processes and some useful heating, not only for the buildings but any other process, pharmacy, beverage, dairy, and etc., then we definitely save the using of fossil fuel and CO2 emissions. This is what about.
Okay, thank you. All right.
It's go outside of that center. Its impact on the whole activity of the people.
Thank you, David. And as we have really, it's not only the international group, in the end of the day, it's also like, say, we have experts from all angles of the data center industry, really from the inside, from the white space to the outside. I think this is also good that we can really cover everything. And I would like to come to Luke, as the CEO of Ethernetics, a Belgium scale-up company, doing at this point of time the most sustainable PDU in the marketplace. Can you share with the audience what are really the benefits of the PDUs and what are really the advantages?
Yeah, thank you. For us, the PDU is a means to capture the data on, I would say, the usage of electricity, the need of electricity at the server level. So we created a really smart, not just a smart, but a really smart PDU that measures the need and usage of electricity at the level of each server. With that data, because it's about, for us, it's about the data. With that data, we can report on usage or avoiding of usage. So basically what we try to do is lower the electricity consumption. So we always say the best electricity is the one that in the end you do not use. We call it a sustainable PDU, but it's much more than PDU. We call it sustainable because it's modular, so you only need to buy the modules according to the number of servers. It's circular, we use as much as recyclable and recycled material, and in the end we produce locally, which is really happy to explore after the session.
Thank you, Luke. All right, Henrik, now it's your turn. So, Huawei, as a full service provider when it comes to data center infrastructure, please can you share with the audience, I'm aware about it, why Huawei is spending a lot of money in R&D. Why is it so vital for Huawei as a company?
Yeah. First of all, Huawei is a very, very sustainable company. So we have been part of UN Global Compact since 2004, and that was actually in that group that the 17 World Development Goals within sustainability within UN was on there. And Huawei, we have haven't counted lately, but approximately 110,000 people work within R&D, and that is 54% of all employees. So it is a huge part of us. And one of the reasons we are doing that is because we believe in the modular and scalable solutions. Also, when we talk about sustainability and circular economy.
Yeah, thank you. All right, Stefan, now it's your turn. As an expert when it comes to data center hardware, can you also share with the audience what is really the benefit of a second life server, a circular economy server, towards a brand new one?
Okay. Well, first of all, it's a cost factor. Obviously, a second life server has huge cost benefits. But then also the scope 3 emissions and the embedded carbon savings significant. If you look at large deployments, if you look at this even like units, basically we decided from the very beginning to offer all event solutions for Facebook data centers and voice operators in Europe and Germany. There is a massive saving if you look at the whole rep, meaning 630, 700 computers. And even those per server, it's like 60, 70%. So yeah, it's the minimum at the cost, and
Okay, thank you. Coming back to Brian, can you also elaborate to your dedicated battery storage and solar solution? The best solution you're offering is really in the light of UK and Ireland on the possible or feasible cost reduction, the carbon emission reductions, and also how to stabilize, or ideally stabilizing the grid with your solution.
First and foremost, there really is no heat recovery capabilities of battery energy storage systems themselves. We can leave that to a discussion with you guys in terms of server heat recovery,
Okay.
etc. In terms of the ancillary benefits of battery energy storage systems, particularly here in the UK, here in Ireland and in the UK, because the grids in both countries are ancient, underinvested in for decades and decades, and now are confronted with renewables which are both intermittent and flow from various parts of the country at various times, most of which are not forecastable. The battery energy storage systems effectively act as a sponge when there's excess electricity, and you can squeeze them and they can push electricity back into the grids, thereby stabilizing them in periods of instability due to the renewables. So that's, I'll call it an ancillary benefit, but the beauty of that is the battery energy storage system and us as owners, we get paid not only to deliver those types of services, but even more elegantly, we get paid just to tell them that we will do it if they ask us. So it's quite a nice revenue stream. In terms of the sustainable end of things, for every megawatt of batteries that we put down on the ground and deliver services to our hosts, we don't call them customers because we're not selling them anything. It's a cooperative arrangement between two organizations. But we spend all the money, we do all the operationals, we take all the risks, and it's up to us to optimize the batteries on-site, near-site solar for best effect. But for every megawatt that we put on the ground and operate, we can save more than 40 metric tons of carbon per year for our contracts of 15 years. So, and a 1 megawatt battery is relatively small. We go up to, the biggest one we're building right now is 233 megawatts, 466 megawatt hours in South Wales. So the amount of carbon that we can save by delivering services to the grid, charging up in the middle of the night when the UK and Irish grid are at minimal intensity, and then discharging them during peak periods, thereby avoiding the need for high carbon swing generation.
Excellent, very good. Coming back to David. David, can you also share some insights, the role of high performance computing, or in particular AI application, on the fact that the density in the server, as we also see in the presentation, is increasing?
Yes, so server producers, they looking for the solutions which will reduce the energy consumption. But in order to do that, you should make closer components of the server as close as possible. This is why we have this small GPU, so where is included many of components. But in this case, we reduce a distance, we reduce the resistance of this transition of the electricity, but at the same time we make that much denser. So this is why we have high dense servers which use more kilowatts, but overall the 2 racks can do the job instead of 10 racks with old-fashioned servers. So the driver is to save the energy. And this is why we have now new servers, which is challenging with air cooling.
Yeah, so basically what you're saying also, the software is really determining the hardware now, right?
Yes,
The performance,
yes. At the same time, we have many enterprises which are happy with the servers, which is 5-10 years old, and they can still use them and air cooling. But we have another applications which can be cloud or high performance computing, which request new servers, new solutions, and it's not possible to handle anymore with existing infrastructure.
Okay. Coming back to Luke, can you also share, when it comes to your PDU, the most sustainable at this point in the market, the big differentiators towards products, similar products, smart PDUs in the market?
Yes, sure. I think what we are doing is we're turning something like a commodity, which is a PDU or a socket, we turn it into a data collection tool. And if you have the data, then you can start managing. What we do is we use that data to look at the electricity usage, to optimize it, and to report on it. And it results in cost savings and reporting its CO2 reduction. So it's quite, I would say, turning a commodity into a very smart tool to manage your electricity usage.
And there's also, let's say, a product when it comes to circular economy, the aluminium, let's say, of the chassis is 100% recycled aluminium, and also it's modular. You can also then, sorry.
Yeah, of course. The product is built in such a way that at the end of the life cycle, we will take it back and we will decompose it and recycle as much as possible.
Yeah, thank you. Henrik, now it's your turn again. So, can you also share with the audience here today what makes you different as Huawei, as an organization, when it comes to decarbonization of the industry and also sustainability towards similar competitors in the market?
I think one of the biggest advantages we have is actually we are thinking for the holistic view of it. So we are already starting to make like scope 3 reporting for companies. So when you buy Huawei companies, you actually can get scope 3 or documentation for the equipment when you go there. So this is one part, and we are hugely engaged in all kinds of organizations within standards, within also how to develop the system. So I think we are very representative there.
Okay, thank you. So, need to look here at my notes here. Stefan, I have another one for you. Can you also share when it comes really to UK and Ireland? This is where you're also operating most of the time, from my understanding, but also on continental Europe. When it comes to, let's say, OCP, open bare metal server, how do you see in your daily work the demand?
Yeah, certainly. The demand, I think, has really gone up sharply. If you look at all the products out there from partners like Gigabyte or Mindtech and on the other side, there are new, very interesting products, and on the other side, there is obviously the openness. Means it's perfect for the reflux side. You can actually configure it, you can access the OpenDMC, you can access every level of the management board. So there's demand going on and more from the
Thank you. Brian, I skipped this one, because there is no really use of thermal heat from your solution, so I crossed it out now. So I will jump if it's okay with you, Brian, or because there's really little possibility, from my understanding, to make use of thermal heat from your solution. Is that correct?
That is correct.
Okay.
We can do a lot of things, but heat recovery, heat utilization, because the lithium-ion cells do not operate at unduly high temperatures. We're limited in what we can do.
Okay. And then I would like to jump to David. David, please also share with the audience. We learned a lot about combined heat compute. We learned about how to decarbonize the data center industry. So can you again, I think you've done it already in your presentation, but again, possibly a bit more detailed, really why, to some extent, liquid cooling, yeah, immersion cooling or cold plate cooling is really needed?
So because now there is demand. Before 1 year ago, 2 years ago, we tried to explain to the market why it's what benefits it gives, how it solves challenges of data center industry. But now we have demand.
Yeah.
We have demand from the customers which have new servers which not work anymore with liquid with air cooling, and they need or on-chip cooling or immersion, and they come to OCP and asking how to do that, where we can get information. This is the first driver. Another driver is the lawyers.
Okay.
Lawyers of data center, because now is new legislation in Germany,
Yeah.
which the demand from data center to make 10% heat reuse, and the lawyers of the data center push engineers and data center to resolve this issue. So they're looking how to make heat reuse. What is possible to do? Is it possible to make that heat rejection to the energy grid, I mean district heating, or they can do something by themselves to create that heat reuse opportunity by themselves, like fish farming, greenhouse, and etc. However, the drivers is demand.
That's a fair point. I think when it comes to legislation, now kicking in January in Germany, I think we can have a separate session, but we skipped this. So I would like to go to Henrik again. Please also share with us, so we said we could see Huawei is investing big time money into R&D. Can you share to some extent with the audience when it comes to latest products, when it comes to your product lineup, also in regards to combined heat compute or really products driving the decarbonization?
Yeah. No.
Okay, thank you.
We are developing quite amazingly, and this is for data center parts. We are looking much into the knowledge, because the knowledge is one of the key drivers for sustainability, but also for heat recovery solutions. But at Huawei, we actually also have some partners in China, some of the Chinese OTTs that have gone very far into developing heat recovery systems. For instance, in Inner Mongolia, we have Alibaba, and we also have Huawei Cloud, and they are using heat recovery big time for the data centers. So this is one part. Another part is, I think it's not a secret, is power to the X.
Yeah.
This is new because we have huge installations with lithium batteries, and this is our energy storage system today. We need to convert to something else.
Fully agree. As we also learned today, I think, yeah, data centers, as you all know, are like really like big power plants, yeah? And then the solutions like you, really, where the battery storage is charged in throughout the, away from the peak times, of course, then you can also use excess heat to stabilize the grid. All right, good. So last but not least here, again to Stefan, can you elaborate when it comes to, let's say, servers, really? Which kind of servers are needed when it comes to liquid cooling? So, yeah, can you really say which are really dedicated for liquid cooling? Yeah, and how you see this technology also as the rest of the audience? How you see liquid cooling?
So liquid cooling, first of all, I think is definitely the way forward. So we have to change something about cooling, and I think it will be liquid in which form. So we work with some kind of immersion with quantum servers, and this works very well, but we need obviously to be able to have dedicated access to switch off certain sensors, to take off fans. So there's a bit of work involved to actually get server immersion ready. And I mean, as long as the manufacturers have to really step up now and for more and more, all we're doing is for more immersion ready machines. And on the other hand, obviously there's also keyboards and easier to access and configure, but immersion is the way forward for liquid cooling.
All right, so I think we have 10 minutes left now. The last question to all panelists, and I would like to start with Henrik and then just go down until Luke. Last question to everyone, so please try to provide a brief answer, that we have still some time for some questions from the audience. Starting with you, Henrik. So Could you share with the audience, again, ideally a brief answer here, what kind of game-changing innovations they should be aware of and should really keep track of, really latest innovations you see coming in the data center industry?
First of all, it is the overall AI solution. And for that part, I talk about energy management as a holistic view for a whole data center. This is what we really need to look into, because this is where we have the control and monitoring system for data center. That was good.
Okay, thank you, Henrik. David, please go ahead.
I will say that it's not innovation change makers. Now is change makers is a customer. So the customer demand for high performance computing, this is the change maker. And another one is the new legislation to be sustainable, to make heat reuse. This is also change maker. Because before that, DataCentres don't want to even think about the heat reuse, but now they should do that. And it starts from Germany, but after that we apply for all the rest of Europe.
As John LeBen is always saying, the prosumers, the professional consumers, and at the same time there's legislation kicking in Germany, but there will, as it based on a European directive, it will also come in other nations or other countries within the European Union. Brian, please also share your view with the audience.
No problem. I've got three, but they'll be really quick. First is the advances in long-duration energy storage, which plays so beautifully to the instabilities in the grid, and there's just no quick fixes. So long-term energy storage, long-duration energy storage, I think will become more and more important, and there's some neat developments on that. Recent announcement, and it's TBD whether it's a game changer or just something that's just come out, but Microsoft's new Maya chip, M-A-I-A, 100, coupled with what they call the Sidekick, which is their bespoke cooling system. If it catches on and it's as effective as it's supposed to be, it could be a real game changer in the immersion cooling and cooling of hot chips. Last one, which I think is the most exciting, although it's sort of down in the weeds, is there's been a research project at Cambridge University in the UK that's been going on for about 10 years to utilize microbes, bacteria, to break down end-of-life compute equipment and to recycle. Effectively what they do is they ingest all of the organic bits of ground-up circuit boards, chips, etc. They also ingest all of the precious metals, but they can't process those, so those are excreted as waste products in their metabolisms. Cambridge University has figured out which microbes do what. They have cultured them and actually genetically modified them to be particularly effective. It's now being commercialized with worldwide patents, and it can be a complete game changer in how end-of-life IT equipment is recycled and the amount of materials, precious metals, industrial metals, etc., which will no longer have to be mined at great carbon expense because the recycling is so effective. It's a fascinating system and one really worth keeping track of.
Amazing, Brian. So yeah.
Just quick, if anybody wants any more details after this, please come up to me. I'm happy to share more.
Perfect. Yeah. Please feel free to reach out to Brian afterwards. Stefan, please.
I'm not quite sure what to say now. Actually, I'm just back from Switzerland. There's a Swiss Data Center Efficiency Association, which I think it's not my course, but it's because we talked about PUE a lot before, and they developed a full stack efficiency certificate, which I think, it's a lot of potential, and I think.
Thank you. Last but not least, Luke, please.
Yeah. Thank you. Interesting, Brian. For me, it's a better integration of the data center operations with the energy market. So on one side, you have the demand for electricity, which has its own, I would say, dynamics, climbing, and maybe probably in a reasonably steady state climbing. On the other side, you have supply of electricity with environmental, with wind and solar, which has much more fluctuations. I don't know the answer, but very keen to see if we cannot devise better business models to combine and to link both with each other and to overcome the operational, commercial, legal hurdles, what have you, to integrate the data center demand for electricity together with the supply of all kinds of energy sources.
All right. I found it really funny because you're a moderate guy and you really keep a low profile. But as you guys know, or probably not aware of, Luke is a serial entrepreneur and also an investor. I can see your eyes already when you heard this idea in Cambridge. You can see the opportunity already, yeah?
I'm trying to wedge myself in there too.
So you
We know a lot about we know a lot about bacteria. So we use a lot of beers.
You have really some good beers. And this coming from a German, you know? All right, so I think we have still 5 minutes left. Some questions from the audience. I'm also happy to come down to hand over the microphone. Some questions to the, yeah. You will be second this time. I come to this gentleman over there.
And talk about energy a lot, like in what's happening? Oh, sorry. You talk about energy a lot in reclaiming the heat and everything like that. Do you think there's in the market, in regards to carbon, embedded carbon, the knowledge and the sophistication to understand the circular economy of that, and be able to use it that road to years come see kind of that utilisation wasn't quite enough, and that it's kind of there wasn't enough drive that where we talk about in Germany where it's at 10%, it should be actually 25% to beat that target to make it carbon neutral or carbon negative.
So this question goes to who would like to provide an answer to this one?
I didn't quite understand. Can you just
Can you make brief overview?
Sorry.
So just in summary, the calculations for carbon, embedded carbon and carbon emissions for heat reclaim, do you think there's a sophisticated enough now that we fully understand what we can do to actually make them more compliant?
Stefan, can you just repeat?
So basically, please, Neil. So it's about you said when it comes to the legislation, also Germany is only 10%. It should be higher. You said at the
as in
at one point.
if they're sending 10%,
Yeah.
we're putting all this infrastructure in.
Yeah.
But the amount of carbon used for all that infrastructure outweighs the carbon saved from utilising the heat.
Yeah. Okay. So basically, the argumentation is basically we're starting in Germany with this at least 10%, making use of the excess heat at data centers, and this was from 2026, from my understanding, and this will also increase the number, but this is the starting point. And he's saying all the effort is done is equalizing than the amount you save of carbon.
Yes, I just want to say that if you are able to make 10%, then they are able to make 100%. You just need to start with something. And another issue that that center provide the heat round year, but the energy grid, district heating, can accept only during the winter time. So this is why it's 10%. But after, it should be increased according to the performance. But we need something to do.
Yeah.
Something.
Sorry, but it's a fair point, yeah, but it's a starting point. As you also can see, it's increasing year by year, this 10%, but of course, we have also like lobbyist organization who try to negotiate this number down. But it's a fair point, yeah, it should be more, yeah. But it will also, I think at least the Germans are starting, and I think more countries, as I said, will jump in on this, yeah. All right, so, John.
Are you sure?
Yeah, please,
Time.
please go ahead.
It's a complicated question.
Ah.
Brian, I like your point about what Cambridge University is doing, and that's because one of the questions I've been asked before we got to it was, we talk a lot about energy efficiency all the time, but we don't talk much about resource efficiency. And I think there's some great infographics by the JRC, the Joint Research Council of Europe, but showing that critical raw materials in Europe, and to meet the green transition, there aren't enough. You can't do it. Basically, we will run out of food there. And the point is that some of these critical raw materials come from geopolitically challenging areas of the globe. Okay, but we do ingest a lot of critical raw materials in the goods, the materials that we consume. So recycling those is really important. It's always been tricky to get to those very easily, in a cost-efficient way. And I think that's really true sustainability. And I think the trouble is, at the very beginning of these kind of conversations, we should define what we mean by sustainability. We should also define what we mean by compute, because there are various different ways of computing. And that's a really complex question, and I'm very vocal, and I won't go into them.
The typical John Summers questions. We really love your questions, and also we love you.
That's layers in a wedding cake. Rare earth metals, perfect example. Actually, they're not that rare. They're actually pervasive around the world. The problem with them is there are very low quantities per ton of rock that you move, and coupled with the fact that it is a really nasty process to extract those metals, as you probably well know. And the vast majority of those are processed in China, which has slightly more lax environmental regulations than most of the world. Much in the way that uranium is not that scarce at all, but the processing is quite complicated, and most of it's in Russia, the vast majority is in Russia. Back to your point on the green energy transition, the amount of materials that are needed in order to affect a new grid and the EVs, and the amount of copper, the amount of almost everything is mind-boggling, and mind-bogglingly energy intensive. So I have a feeling, in fact, there's going to be a big pivot away from net zero, green, electricity, and fossil fuels, unless their carbon stocks are going to reassert the fact that they run the planet. And although everybody wants the planet to be as clean as possible, nobody wants to not be able to move around. Nobody wants to have their family in freezing cold houses. So I think fossil fuels will be around for a long time. And when you couple the green energy transfer with the amount of fossil fuels that you need to consume to get them out of the ground, processed, and made fit for purpose for whether it's a new transmission network, electric vehicles, air source heat pumps, the whole range just is super energy intensive, and it's going to be a pyrrhic victory if we pollute the planet, getting the materials we need to get to a green transition. So I'm completely with you.
Thank you, Brian. Are you happy with at least a bit with the answer, with the feedback? John?
That's what it's saying as it should be, and that's how it should be. So we've got to face the fact.
Yeah.
Pretty much true, yeah.
All right. I think we are already at the end of this session. I think we are a bit over time, 2 minutes here from my understanding. Thank you very much for the audience. Yeah, it's 4 o'clock that you also stayed with us. Please give a big hand to our panelists. As I said, we were in a position to have an international team focusing on all aspects of the data center industry or of the data center side. So thank you very much, and we are still around. So we are also around tonight and tomorrow. Also feel free to come by our booth 108 at the OCP booth. We are more than happy to continue our conversation here. Thank you very much. Thank you.
Ja, hier. Dat is oké hoor.